Hi, I'm Judd. This is the second video in my series about how to solve Knight's Move Sudoku puzzles. So I'm going to be going over a puzzle I made called Commander Fox. So let's look at the rules. Normal Sudoku rules apply, so the digits 1 through 9 in every row, column, and 3x3 box. Cells separated by a knight's move may not contain the same digit. We did that in the last video. So knight moves 2 and 1, so up 1 across 2. Those can't be the same digit because this 3 sees that 3 by knight's move. Alright, so that's the same. What's different? Well, in this puzzle we have clones. So the entire gray area here is clones, but it's two different clones mashed together. So I have also colored them with cages. So the 4 cages are clones. Cages are just the dashed boxes. They are labeled. So here is a cage called Y. Here's a cage called Y. So we are saying that these two are clones of each other. Cages of the same color must have the same digits in the same location. So if I put a 3 here, that's in the upper portion of the clone, so the 3 must be in the upper portion of its copy. And then X has a clone down here, so notice they're the same shape. Digits may repeat in a clone, so normally in a cage you cannot repeat, but here I could put a 3 here and a 3 here, because I'm just really using the cage to be a different color to let you know that this and this are the same. And all cages must sum to an even number. So at the end of the puzzle, when we're figuring out what the numbers are, that's going to help us differentiate which numbers go in a cage. White dots are consecutive. We had white dots in the last puzzle, so that just says that these two numbers are next to each other. If that's a 3, then that could be a 4, or it also could be a 2. They just have to be adjacent, consecutive. And finally, adjacent digits do not sum to 5 or 10. So this is a common Sudoku constraint using Roman numerals. So between these two cells, if there was a V, that would tell us that these two cells sum to 5. And if there was an X, it would tell us that these two cells sum to 10. So this could be a 1, 1, 4, or it could be a 2, 3, or a 2, 3 this way, if there was a V here. So this is an XV puzzle where there are no X's and no V's. So no two digits next to each other can sum to either 5 or 10. Alright, so how can we solve this puzzle? Well, a standard way of solving Knight's Move puzzles, we don't have any given digits, so we're going to color instead. So we might say that this digit here is a red digit. That's the third one down in the Y clone, so that would mean that's a red digit. So red is just standing in for, that's a digit 1 through 9. We don't know what the digit is, but we know that it's the same digit between those two. So we're just showing the relationships between those two cells. And then we can use Sudoku. Alright, well, if we have a red, where does red go in row 4? Well, it can't go there because there's already a red in that box, and it can't go there. And so we could mark down that there is a red cell in one of those 3 locations. Now, in the first puzzle, we used coloring, and that worked great. Because we had lots of different relationships already given to us. So we had green in the right, we had green on the left, we had green on the top, we had green on the bottom. We could put lots of, oh, green could potentially be here. No, that conflicts with what's over here. And we could go across the entire grid and we could solve for one color. And then once we got all the greens in the puzzle, we could move on to the blues and figure out where all the blues were in all 9 of the 3x3 boxes. And then when we figured out all the blues, we just make up a new color and we go around the entire grid and we fill that in. Now, if we tried that in this puzzle, Well, this is the only two things that we know are red, so that's as far as we're going to get. We would end up filling in, oh, well, this entire box can be red, and this entire box, except for this one square, that can't be red because that sees that through night move. Like your entire grid would be filled up with pencil marks. So that's not going to work very well. So instead, for this puzzle, I'm going to recommend a different approach. And that is, instead of assigning colors as you go, you want to assign all of the colors up front. So I need some way of knowing what 9 unique digits are so I can color them 9 different colors. Now, knights have a limited distance that they can see. So if I know that this digit is a 1 over here, that doesn't help me solve the puzzle very much, because that doesn't tell me at all where the 1 is here or here. All it tells me is, well, there can't be a 1 in any of those squares. The knight has not helped me because the 1 is so far away. If I put a 1 here, however, well, that's closer. Well, all of a sudden, I still can't see anything in that row, but that sees that by knight's move, and it sees that by knight's move, and it sees that by knight's move, and it sees that by knight's move. So we're limiting things. So knights see a limited distance. So when we're coloring things, we want to choose something. We want things to be close to each other in order to solve. So one way of doing that is we could start by coloring this central box, because if we color this box up here, it doesn't give us any information down here, whereas if I color this box, it gives us a little bit of information in all the rest of the 3x3 boxes. So that's one approach we could do. For this puzzle, I'm going to do something slightly different. We also know that the rows and the columns have 9 unique digits in them. So I'm going to choose a column. Why? Because it matches the closest to my givens. So this has things on it, this has some on it. So I'm just going to choose, all right, I'm going to make this red, and then we go along and I color each of these cells, and we start from there. So we're going to start with all 9 colors instead of adding them as I go. So that's one change. However, as we go along, we're going to try and solve this puzzle. We're going to say, all right, there's a peachy color here. So over here, I'm going to have a peachy color. It can't be in those squares. And a yellow means the yellow's there. And the pink means that's in one of those squares. And then we don't really have very much information about blue and purple and red and green. And blue can't be there, but it can be there. And oh my goodness. Like, is this actually helping you to solve this puzzle? Like, there's peach and pink. I have a hard time telling them apart. And what's the relationship? Like, the yellow stands out, so maybe that helps me, but this isn't really helping me very much. These pencil marks learn the relationships. Like, what goes here? Oh, I have to know what's over here to match with what's here to decide what's here. So I'm going to suggest a different approach for this second puzzle. So I'm going to restart. And let's move here. So if you choose this settings button, up here there is an option to turn on the letter tool. So I've got that turned on. Now I'm going to go back to the numbers. And notice on my number pad there's a button down here which can change between the letters and the numbers. So I'm going to choose letters. So for this puzzle, we are going to color, but we're going to color not using colors, we're going to color using digits. Letters. Now, why would you want to do this? Well, let's say that I had determined that there was an H over here. And then later I learned that H goes there. Well, notice what has happened. These have turned red because the tool treats the letters like they're numbers. So there can't be an H here because it's in the same column, and there can't be an H here because of the knight's move constraint, and the tool knows there's a knight's move constraint. So if these were just, I think red is somewhere over here, whoops, and then I make that red, you might say, oh, well, that can't be red, and you might miss the fact that there is a knight's move constraint. Now you're not going to miss it because it tells you, it makes this, because we have conflict resolution turned on, because we're new people trying to solve these puzzles. It's going to help you figure out your relationships easier. So it's going to tell you that that is your H. So that is going to be handy for us newbies. All right, so now that we've made a couple of changes, we have given digits and we have not colors, we have letters. Let's try and start the solve for this. All right, so we have a clone. So we know that those digits are there. We have a clone here, which comes down to here. So where do we start? Well, the clones are good because the clones have relationships. So if I pick this square, that's the same as that square right there. So if you want to be really lazy, you just put in, oh, this is an A, B, C, D, E, F, G, H, or I. And notice the tool is telling you through the red, oh, well, this can't be an A, B, C, D, or E because it sees them all. So I'm going to remove A, B, C, D, and E. This down here in the bottom says, well, this sees an H and I, so that can't be an H and I. So we've learned that this clone is either an F or a G. If you want to be a little more clever and not let the tool do all the work, then you just manually do this. So this is in the same box with A, B, and C, so that's not right. This cell sees D, so that's not right. Oh, we have an E and an F, so this can be an E or an F. We have G, H, or I, but this cell sees all three of those, so we're done. We've pencil marked. All right, we should keep doing this with the clones because that's going to give us relationships we need. But I want to talk about a couple standard patterns that you should look for when you are solving a knight's move puzzle. So the first pattern I'm going to call a knight's line. I don't know if these have names, so I'm just making up a name, so you'll never hear anyone else call it the knight's line, but that's how I'm going to refer to it. So what you do is pick any cell that's not a corner cell. So I'm going to pick E. Now we know from Sudoku that E is not in any of those squares. But the knight's move gives us additional information we don't normally have in Sudoku, and that is, it's also not in any of these squares, because these two are seen by E because they're a knight's move away. So I'm going to just draw that. That's the knight's line. It has a wall. It doesn't want any other E to get too close. So that's good because it gives us additional information. We could potentially pencil mark E. Oh, well, look, that tells us there's an E up here. And say, all right, E goes down there. I don't recommend that you put an infinite number of pencil marks in your puzzle. It's just going to get as complicated as when I had 9 colors in a cell. But if you can limit it to a couple of different cells, then you put in where it can be, and that'll help you later. All right, so let's see if we can use that to help solve our Sudoku. I am going to pick G. Why? Well, G is a great cell. G is adjacent to a 3x3 box, and it's also not a corner, it's in the middle, so we can use our knight's line idea. So we know G isn't here, and G can't be here through knight's move. So that tells us that G is in one of the corners. But again, we already had a G, so it sees those two. So we've limited to 2 different locations where G can be. So that's the use of the knight's line. Second pattern I want to introduce is what I'm going to call the knight's triangle. So G here is interesting because if I put a G here, notice this has G in the cell. Well, this can't be G if this is G because it sees it in the same column. But also, if I put a G here, this can't be G because it sees it by knight's move. So notice we have a little triangle shape. Before, we said if you did a non-corner, if you choose an edge or a middle, that you can do the knight's line. Well, this knight's triangle is if you have a corner, it takes 2 other corners out. So because G can go in only 2 spots, this can't possibly be G, because then I could not put a G into box number 5. So that means this must be an F, and if that's an F, that means these 2 must be E's. Whoops. And there we go. We've made a start on the puzzle. I'm going to leave the rest of the puzzle for you. I suggest you try it. It's fun. I really like the ending here. So notice we have just 1 dot in order to differentiate all the different numbers. So once you fill in the entire puzzle with A's through I's, you have to figure out which ones turn into what numbers, and this is really the biggest information to help you do that. So that's fun. As you go forward, focus on the clones because there's relationships here. Focus on the middle box because it can see a lot of different cells. So focus on the cells closest to the cells that already have information in, and that'll help you. Save all this stuff out here till the very end because that sees the least. You have the least amount of information in order to solve those. Good luck!